Hey folks, sorry about that. I did that once again, and sorry for the last 3 minutes. You haven't heard me say anything. Anyway, it looks like a lot of people have logged in, and um, let me start over here. Sorry about that. So, what we are going to do in today's episode is that we are going to recreate this figure that I published as part of a paper in the journal MBio. I want to say about 6 years ago, maybe 5 years ago. And what this is looking at is the ability to classify people as having a normal, healthy colon versus a colon that's got lesions that are indicative of progressing towards colon cancer. And so what we wanted to do was use the bacterial taxonomic information to make that classification. So we had about 500 subjects in the study, somewhat evenly divided between healthy and cancerous. And as microbial ecologists, we can look at different taxonomic levels of resolution to classify our bacteria, right? And so there's a tendency to get more specific. So that's kind of the bottom of this plot, ASVs and OTUs. That the more specific, the better, right? That's kind of a philosophy that is pervasive in the microbiome field. I think that's actually not true. And this data, I think, actually helps to show that, right? Meanwhile, at the top of the plot, we have the phylum, which is the broadest possible taxonomic level. And we have levels in between, right? And the question then was like, at what taxonomic level do we get the best classification? And so we have two metrics here, area under the receiver operator characteristic curve, and the sensitivity when the specificity is set at 90%. And so an AUROC, or area, the receiver operator characteristic curve, on the x-axis has 1 minus the specificity, and on the y-axis the sensitivity. So you get this curve, and the area under that is what's being measured on the left, whereas again, on the right, we have the sensitivity when the specificity is set to 90%, okay? And so you basically pick off 1 point. And so I feel like this sensitivity is perhaps a stronger metric of the model performance, but regardless, by both methods of looking at this, we see that family, genus, and OTU perform similarly well and better than the other taxonomic levels. And so it's not getting more specific to like the ASV levels to have a stronger classification. There is a happy middle ground. And so we call this the Goldilocks effect. So if you're not familiar with Goldilocks, she's this little girl who broke into the house of 3 bears and was eating their porridge and found one was too hot, one was too cold, and one was just right. And so our point was that family, genus, OTU is just right, at least for this problem, right? And so for other questions, it might be ASV, it might be phylum. Who knows, right? It's going to vary by the question you're interested in. So the audio should be working now. I know there's a little bit of delay in me talking and you hearing, but if somebody could say that you can hear me, that would be awesome. I am sorry that I continue to have these audio challenges when we get going, but I think it should be working now. And so the question that I want to take on for today, and that I've been discussing in the critique video and the newsletter that came out earlier in the week, was how should a figure differ if it's in a paper versus in a slide deck? And so in the critique video, I kind of mocked up this version of the slide showing a title, and the title having color that corresponds to what I want them to see, the audience to see in the panel. And I've stripped out a lot of the data that I think is important perhaps for like specialists who really care about, how are the hyperparameters tuned? How did you do your cross-validation? All those types of things, right? And just really stripping it down to the basics of what is the question or what is the story I'm trying to tell. Because when I go somewhere like I did last week, I went to Syracuse University and gave a talk where I had a slide that had this directly in it. And I was thinking, oh my gosh, Pat, what were you doing? That I'm trying to explain all the stuff, right? All the stuff perhaps about cross-validation, about what sensitivity, what specificity are, what the different taxonomic levels are. And meanwhile, they're trying to like ingest what the figure says. And so I feel like by stripping out a lot of the details that again are perhaps important to like the specialists and people that are really going to geek out about the techniques and stuff, might be important to them. Alternatively, if I strip a lot of that out, then it becomes much more clear, perhaps, what I want them to see, right? And so, again, this was a mock-up I made in PowerPoint and with preview, kind of deleting things in the background, and so things got stretched. I don't want ovals as plotting symbols, but this is kind of along the lines of what I might think about making for a presentation, right, in terms of a slide deck. And so what I'm going to do today is we're going to recreate this set of panels because my thinking has evolved over time in terms of like how I would present this data. And then we're going to take this and modify it to make something like this, okay? So that is the plan for today. If you are just joining, I do have a website, rifamonas.org, and this will be kind of a landing site for a lot of the different resources that I offer. I also have a mailing list I would encourage you to subscribe to, and you'll get a weekly email from me where I kind of talk about a data visualization from kind of a 30,000 foot view. Very little code, but much more kind of a narrative story. The other thing that I will share with you is the original paper that this data is drawn from. And like I said, this was published out of my lab with Courtney Armour, who was a postdoc at the time, who did the bulk of the analysis along with Begum and Andrea. And so, yeah, like I think it's just a really cool story, simple story. This was an observation format, so you get one figure, and that's the one we're going to make. And also here is the newsletter that went along with that I will throw into the chat here. And I then also have this critique video, which I will also throw into the chat if you want to go back and watch that as well. All right. So let's clean some of this up. And like I said, we are going to use R to recreate this visual. And so I already have a script created. And I think okay, anyway. So I have a script created in a directory that I'm calling paper v talk or slide or whatever you want to think about it. But before I go on, I want to just call out the people that are joining us and thank you for your patience with my audio difficulties. So we have John from Barrington, Illinois, Saeed from Somalia, great to have you, Hassan in West Virginia, Lori in Toronto, not sure with CSS where you're from, and yeah, and we've got Mark, I believe is in the UK, and I think I saw Mike P also I think is in the UK. So it's great to have you all joining back, and again, thanks for your patience. So as always, I'm going to get going here in RStudio by doing library tidyverse, and get that loaded, and yeah, and so we're off to the races. So the data that we're going to use again is from this paper by Courtney Armour in MBio. And so in my lab, what we do to foster reproducibility and transparency is we put the code for the analysis, the manuscript that we write as Quarto or our Markdown documents, as well as the final process data into GitHub repositories. And we then include those links in the manuscript. And so this GitHub repository, can also throw that in here. And oh, Mark is in Melbourne. Awesome. And we then have Kislin in Chile. And so I think we have all of the continents represented. That is awesome. Actually, maybe we might be waiting on someone from Asia, but otherwise we're doing well, and hopefully someone will log in. Still waiting for that person from Antarctica to log in. So anyway, like I said, this is how my lab does things. I am a big fan of this because if I want the data or the code for a specific paper, I can go to this repository that's part of Schloss Lab, and it's just all there, right? And then we try to have this nice organization of our repositories and our projects, right? So if I want the code, well, I can click on this link for code, right? And then I want the R code, and then I want the code for the figures, right? And so here's the code for figure 1, right? And so let me see if I can, yeah, there we go. And so this was all written by Courtney with my direction. And so she used cowplot to, I think, assemble the two panels together. I'm going to try to do this without cowplot. Maybe we'll use patchwork. Maybe we won't. We'll see. And so what I don't want to like rerun her code. What I want to do is figure out where the data are. Right? So I'm going to look at the code to see where the data are. And so looking through this, I see what? So here's the read combined. And so there's a data process combined with a taxonomic level model.csv. And so if I come back to the root of this project and I go to data, where's process? Process, and then combined, and then we have the different taxonomic level and the modeling approach, right? So what we ended up using was random forest, so RF, and random forest performed better than, I don't know, I think we did 1, 2, 3, 4, 5, 6, maybe 5 different modeling approaches, and random forest performed the best, right? And so we have this combined, the taxonomic level, the rf.csv, okay? And I think that is for the AUC plot, and then for the other plot, the sensitivity at 90% specificity, then here we have, it's an analysis send spec by level. Okay, so we've got 2 types of data frames, and again, I can see those are all here. And so like if I click on this combined ASV, RF, CSV, I get, it's a CSV and GitHub is rendering it like this. Ultimately, I'm gonna want the raw data. And so if I click on raw, I can see what the raw data actually looks like, right? So I'm gonna go ahead and copy this URL. And the first thing that I'm gonna do is to create a variable, a vector that is the path or the URL for all of the different taxonomic levels we want. So I'm gonna use glue, so we'll do library glue, and that is installed with the tidyverse. And let's go ahead and do tax levels. And I think she did it in all lowercase. Let me just double check that. Come back here. Yeah, so class, family, genus. Yeah, so it's all lowercase. So we'll do phylum, class, order, family, genus, OTU, and ASV, right? And hey, C Mumi, welcome. Let us know where you're logging in from. And I'll go ahead and wrap this path in quotes and do glue around that. And so then what I'm going to replace is this ASV with curly braces and then put in tax levels, right? And so then when I run that, what I get are different paths for each taxonomic level that you can see here, right? So that's cool. So that's the path. So I think what I could go ahead and do is pipe that to read_CSV. And read CSV will read in an individual CSV file or a vector of file names and make a single data frame, assuming they all have the same column names. So when I do that, I take randomization splits between a training data set and a test data set. And it's got 7 taxonomic levels. But what you'll notice is that I don't have the taxonomic level here, right? And so what I could do is I could add to read CSV, I think it's ID, and I will say level. And then what that does is in the level column, it's putting my path, right? So I don't want the path, I want the taxonomic level. So I'm gonna go ahead and do a mutate on level, and we'll do str replace, and I'm gonna do like basically everything. So that's the dot star. We're gonna put in a regular expression up to like combined hyphen, right? And then I'm gonna use parentheses to save the information that's between that combined hyphen and the hyphen rf.csv, right? And then I can say, replace that with back1, but I need to give it the variable name that we're going to do this search on, right? So we're going to take the level column and we're going to run str replace on that. We're going to search for this pattern, but in those parentheses, I have to put dot star, and the parentheses are going to store whatever dot star matches and then use that to replace. And so when I run this, we then get all of those taxonomic levels. All right. And so we've got, see, Mumi is logging in from Dublin, Ireland. Great to have you. All right. So, great. We've got that. And let's go ahead and select for the data we want. So again, what I want is the AUC and the phylum and probably the seed. So let's go ahead and do that. I should also point out, like, this specificity and sensitivity are what it's picking as the optimal sensitivity and specificity. And so it's not what we want in panel B, because in panel B, we want to set a single specificity for all levels and then use the sensitivity that corresponds to that specific specificity. So what we're going to want is the AUC. All right, and so let's go ahead and pipe that to a select, and we'll do level, and then I'm going to do AUC equals capital AUC, and we'll also include the seed. And so just because, let's do seed like that. And so now we're going to have 3 columns like so. And I don't know if you notice it, but like it takes it a beat to load this. And that's because it's downloading these 7 files from GitHub. I'm going to go ahead and call this AUC data. All right. And so then we can work with AUC data without having to like re-download things over and over again, right? All right. So let's think about plotting the data. And so again, if we look at this plot, so let's look at this version of the plot. Again, we're thinking about panel A. We're going to put the AUC on the x-axis, and on the y-axis are taxonomic levels. And then we're going to plot the data using geom jitter, right? Because these are jittered data. So let's start with that. And so again, we can do ggplot AES. On the x, we'll put AUC, and on the y, we'll put level. I'm going to leave it like that for now, and then we'll do plus geom jitter. And let's see what that looks like. And there we go. And so we've got these black points here, and the height of the jitter is probably higher than what we really want it to be. But ultimately, what I encourage people to do is to save files into the size that you're going to publish it in, right? So if I come back and look at Courtney's code, down at the bottom, she probably has a GG save, right? With a height of 3 and a width of 6. So let's go ahead and do the same thing. So I'll do GG save width. For now, I'm going to do 3 because it's half the plot, and height equals 3. And then I will call this, let's call this panel A.png. All right, so running that, and then let's open up panel A PNG. We get that. And again, that's pretty much half of the overall figure, right? All right, so something like that. Cool. All right, so I'm going to put these next to each other so we can see how this develops or how things might change over the process. All right, so that cloud of points is too tall, right? Like these points kind of run into each other a bit. So let's go ahead and in geom jitter, I'm going to do position equals position jitter. And that is the natural position of a jitter plot, of a geom jitter. And I'm going to do this for mainly setting the seed, right? So if I do set seed, if I do seed equals 1976 06 20, then every time I run this code, so if I run this, I get that, and if I run it again, nothing changes, right? So setting the seed within position geom jitter will fix the seed. But we can also do like height, and I don't really know what it should be, so let's try 0.5. That didn't do what I wanted. Let's drop it to say 0.2. And so that brings it in. We can make it a little bit wider. So maybe let's do like 0.3. All right, let's split the difference and do 0.25. I think originally it was 0.25. And so one thing I actually noticed in the critique video was that on the left it was 0.25 and on the right it was 0.2, which probably no one in the world but me noticed. But these little things I tend to notice. All right. All right. So sorry if the lag and the latency and the connection seems to be a little bit spotty this morning. I'm sorry for that. I think that's kind of a downside of doing these as live streams here. It's just my internet quality isn't always what I'd hope it to be. So anyway, thanks for your patience. All right, so let me pull that back up. And there we go. And yeah, so one thought, so I think I'm going to try to do this with patchwork. There's a way that I could imagine doing it with facets, where we would have two facets, and we could, because you have to have the same like axis title for the x-axis or y-axis for a facet, there's a trick we could do where we could like basically use the strip title, move them to the bottom, and then set them outside. But because ultimately I'm going to want each of these to be a separate panel that I can use in a talk, I think for today's purposes, I'm going to go ahead and put them separate. And if we have plenty of time at the end, maybe I'll come back and show you how I do it with facets. But for now, I think I'm going to end up using patchwork. So make two panels and then bring them together with patchwork. So, all right. Okay, so one of the critiques I made in the critique video is that the color here is extraneous. It's really not necessary. And so I think what I'd like to do is turn these background points to be like a light gray, but also to have some alpha to them, so that the points that overlap with each other, we can kind of get an idea of how many points there are. So let's do like color equals gray 90. Let's see what that looks like. And then do like alpha equals 0.5. And oh, I lost it. Okay, let me bring it back up. Okay, so they are there, but we can't see them because of the background. So let's go ahead and turn off the background. And actually, the theme that Courtney used, I believe, was theme BW. We can look at her code. That's one of the nice things here, right? Theme BW, right there, right? Okay. So I'm going to add that. And we'll probably make some modifications to that as we go along. But there we go. We have those. And maybe that's too light. Okay, so let's go up to like 70. And all right, I'm gonna split the difference and go back to 80. All right, so I want it to be like a light gray. So now what I want to do is to go ahead and draw the symbol, draw the mean of these 100 iterations with plus or minus a standard deviation, okay? And so to do that, we are going to use stat summary, and we'll come in here, and after the geom jitter, I'm gonna do stat underscore summary. I'll do geom equals point range, which is the default. So that's the circle with the bars. And then we'll do, I think it's fun. It's either fun or fun data. But then we can do like underscore SDL. And I believe that gets us 2 standard deviations. So we'll come back and do 1 standard deviation. But it's upset with me. Maybe it's supposed to be fun.data. There we go. It is fun.data. And We get that. That is plus or minus 2 standard deviations. So to bring it down, if I recall from last time we did this, it's fun.args equals a list, and we can then do molt equals 1 to make it 1 standard deviation. No errors, that's always good. And that then gets us down to plus or minus 1 standard deviation, right? Cool. All right. And so I like that. And one thing I'm noticing as I look at this, of course, is that my y-axis is not in the same order as what we want it to be. I want it to go from taxonomically broad down to something more narrow. And let's see. All right, I'm seeing that there's maybe some lagging going on, and I'm sorry about that. Hopefully we're doing okay anyway. I'll press on, and yeah, there we go. We want to get the y-axis to be in the correct order. So to do that, we'll use a factor. So by default, it goes alphabetically from the bottom to the top, okay? So let's come back up here where I defined tax levels. And what I will do is set those as the levels that I want for my data, right? So I could, let's do it up here where we're defining the data. So we'll do mutate level equals factor on level, and our levels I will set to be tax levels. Okay, so we'll run that, and then we'll run this, and I suspect that things are going to be the opposite now of what I want, right? So we have ASV at the top and phylum at the bottom. I'd like to flip that, and so I can flip that where I am defining the levels here. I can do rev on that. And there we go. We have phylum at the top and ASV at the bottom. And so there we go. We've got the right order. And so Mark asks, also in Factor, you can change labels for capitals. That's right. So let's go ahead and do that. So we can come back up here to Factor, and we can do labels. Oh, and I think I went inside too many parentheses. We can do labels equals, and maybe what I'll do will be like tax labels. And then I'm going to copy this down, and I'm going to capitalize the first character. So there is a to title, str2 title, that we could do on like tax levels. And that only capitalizes the first letter, right? Whereas like OTU and ASV are, it's an acronym, right? So they should be all caps. So I'll do this by brute force. I could probably do that programmatically, but this is okay. All right, so we'll get this loaded. And then down here again, within labels, we'll put tax labels. And then let's, yeah, there we go. All on one line. Run that. There we go. All right. So my idea for this figure would be to not make it totally like grayscale, because I want color, which is probably why we put color in here, because we want it to be pretty. And so I think what I'm going to do is I'm going to make family order and class. This isn't doing what I want it to do. Oh, you know why? Because I reversed the levels, but not the labels. That's dangerous, right? So we want, yeah. Let's see. Too many windows. All right. Now when we look at this, this looks right? So phylum is at the top with the worst quality, comes up, and then is level at family, genus, and OTU, and then comes down for ASV. Okay, that works. So what I was saying, I want to add some color to family, genus, and OTU to make it clear that those correspond to this group D that are similar, than the same statistical group as each other, and that they performed better than the others. Okay, so I'm going to make family, genus, and OTU, I think like a Dodger blue, one of my favorite colors. And so I think we'll come in here and I'll do mutate. Actually, let's come back up here into the data and do another mutate, add to the mutate, and we'll say group D equals, and I will do if, or no, we'll do level percent in percent, and then I'll do, I have to do capital because I've changed the labels on the preceding line, right? So family, genus, OTU. And so that will be a logical, right? So this says like, is level, the value in the level column, within this vector? And so when we run this, then I can add here like color equals group D. And might not, oh, that works, right. So now we have our point range is changed by the color, right? And we're going to want to change that color to, I don't know, be something more attractive. So HCN tab asks, what's your opinion on dark versus white background for PowerPoint presentations? I don't know that I have a strong opinion. I've gone to like a white background on everything because it's easier for me to put together the slides, in all honesty. Sometimes things have a transparent background, sometimes they don't. And I don't have to worry about that if I just make everything a white background on the slide. Even if like, say this has a transparent background, then that white's gonna show through and I don't have to worry about things getting washed out. I think it's also kind of like a more of a minimalistic aesthetic to have white background than to have black. I mean, there are some slides that I will make have a black background. So like if I had like a picture that I wanted in the middle of the picture, in the middle of the page, or say I blew it out to the whole size of the slide, but maybe there's like letterboxing on the top and bottom, I would make that black so that that black kind of fades into the rest of the screen rather than making it like a white letterbox. I don't know. Like that's kind of my general sense of how I do things. So then let's go ahead and do scale color manual, and I will do breaks. Oh, let's do it as a vector. So we'll do values as a vector, a named vector. So we'll do false equals, and here I'm gonna make this like, let's try black as a starting place, and then true, I'm gonna make Dodger blue. So I have to put these logicals in quotes because otherwise it'll turn it to like 0 and 1. And I think like it's not gonna work because I don't have 0 and 1, I have true and false, right? So let's go ahead and do that. And there we go, we have our black and our blue. I could see making that like a darker gray instead of black. So if I did like gray 30, something like that, I think that looks pretty good. So I'm gonna suppress this legend, and that legend is being created in stats summary. And so I will come back up here and I'll do show.legend equals false. And so then that gets us our spacing, which I think is good. Yeah, so Mark says maybe the background would depend on the illumination of the theater. Lights off white, lights on darker. Maybe, yeah. And I think it also comes down to practicality, right? Like when I gave this talk last week, I didn't know if it was going to be dark or light or what kind of room it was going to be, right? Maybe if you're giving a presentation, it's like, you know, our students have a seminar every Friday at noon and they know what the room is, they know how it's set up, so they can really design for the room. But if I'm coming in for one day and I give like, you know, a handful of talks every year, I really don't have the ability, practically speaking, to do it. Maybe if I'm giving like a TED talk or a keynote talk at some big conference, I would think about doing that, but it gets kind of hard. So anyway, But I think what's more important is making the data in the slides easier to view rather than just overwhelming people with data. So anyway, good questions. All right, so I'm going to go ahead and modify the labels. Before I do that, I want to point out another critique I had and that I've made in various videos is that I am not a fan of putting acronyms in figures. I'd like to think of this figure as standing alone on its, on its own outside of the paper. And so if you come and look at this and it's like AUC, what's that, right? And now if you know about machine learning and classification of these things, you're going to know what that is. But it just adds jargon that's not necessary. I've got space, right? The reason we write AUC is because it's shorter than area under the receiver operator characteristic curve, right? And we write OTU because it's shorter than operational taxonomic unit. But in a figure, we've got kind of plenty of space. So let's use it, right? So I'm going to go ahead and change this to be area under the receiver operator characteristic curve. So I'm going to move that up actually to before theme BW. And we'll do labs. On the X, I'll do area under the receiver operator characteristic curve. And I mean, we could play with, I guess if we gave it title case, we would make all these the first letter capitalized. And then we probably want this to go over 2 lines, so I'll put a backslash in here. All right, and then we can do y equals null to turn off the y-axis, because I think it's obvious that these are going to be taxonomic levels, right? Cool. And again, if I put this down next to it, I noticed that in black white. So let's come in here and do plus theme, and we'll do panel dot grid dot major dot y as element blank to turn off the horizontal grid lines. And then we would like our major and minor grid lines to be the same thickness, I think. So I'd like them all to be kind of like a thinner grid, because I don't think they're super critical, but who knows? So we'll do panel dot grid dot major dot x equals element line, and we'll do line width equals, say, 0.2. And I'm going to copy this down, and I'm going to make the minor one 0.3, and I'm going to do 0.2 and 0.3 because then I can look at 2 values of this and see which I like better and then pick that. So there we go. Which do I like better? I think I like the thinner one better. I'm going to roll with the 0.2. So I'll make this 0.2, and there we go. We now have those thin grid lines for everything. So Mark asks, would you not use a footnote to explain acronyms to save space on X and Y expansions? I think it depends. Like, if it's like a, I mean, if it's an acronym that I'm defining in the figure, but that I wouldn't use an acronym in the figure that I haven't already defined in the paper. Like that caption that you're, I think, calling a footnote isn't going to move with the figure, right? Like, it's not going to be embedded in the figure. Ultimately, it probably does depend on like your space availability, but like this, I'm going to shrink, and I'm already anticipating that the one on the right, the panel on the right, the sensitivity is going to be like sensitivity at 90% specificity. And so that might be long, and I want that to go over 2 lines anyway, right? To add clarity. So I'm not so concerned about this being 2 lines. So I'm okay with that for now. Can you embed in a figure a caption? Yes, you can. Yes, you can. But again, like what I'm trying to do right here is for a paper figure, right? Like in labs, I could do like caption AUC equals whatever, right? And then you'll see that that shows up down here, right? So by default, it's right justified. And that might be something we think about for a figure, but probably not for a I'm sorry, figure in a talk, but probably not in a paper. So, because the text that the journal provides option is going to serve that purpose. Okay. So let me just remind myself where we were. Okay, we were messing with those lines. So these tick marks are kind of chunky. I'm going to go ahead and remove the y-axis tick marks, and I'm going to make the x-axis tick marks the same thickness as the grid lines. So let's come in and we'll do axis.ticks.y equals element blank. So again, that gets rid of those y-axis tick marks. And then we'll do axis.ticks.x, and we'll do element line, and we'll do line width equals 0.2. And so now these tick marks are the same thickness as the grid lines. So I'm happy with that. Let's go ahead and make this text for the title a bit smaller. And we'll come down and I'll do axis.title.x. We'll do element text. Let's do like, I don't know, I forget what the default size is, but let's try 8. And so that did shrink it. And I think that's more along the lines of the size of the original. So I'm pretty happy with that. We'll get to the presentation here in a minute. And let's go ahead then and think about like this OTU and ASV. I feel like that is jargon, but perhaps less worrisome because why? Because it's like a pretty standard nomenclature in the field. So, and I think what I'm going to do is I'm going to switch the order of this to define the group D first, and then turn the level into a factor. And so then I don't have to write out OTU. So let me just double check that this still works. Good, that works. And so then what I'll do is I'll come back up here and make this like operational taxonomic unit. And I'm going to put this over a couple lines. If I can figure out how to type, \n, and then amplicon sequencing or sequence variant. Okay, and let's put this over a couple lines there. Okay. And there we go. So that's really tall. I can probably shrink the line height. So let's go ahead and let's see what we can do here. So let's go in and do axis.text.y equals element text. Let's do size equals 7, line height equals, let's try 0.8. And so that, I think doesn't, like that adds to the left side of the plot for sure. I don't know. Oh, I guess I mixed my capitalization, right? So let's make that capital T, capital U. I don't know. I could go back and forth on whether I want to use OTU or ASV. I think I would like to make it left justified because I think it looks weird for this to be right justified as I have it. So I can do that in here in this axis text XY, do hjust equals 0. But again, yeah, I think I might go back to OTU and ASV. I don't know. Let's leave that and we'll come back to it, okay? So there's two things I still want to do with this. So the first is the grouping information as well as this dashed grid line. Because I'm thinking on the left side already, let's go ahead and do the dashed grid line for 0.5. And so one of the critiques I made of the original, if I can zoom in here, is that it's got the light gray grid line, but then it has another dashed kind of darker gray grid line on top of that, right? And so let's go ahead and put in the dashed grid line. So I'm going to do that with geom vline. And so I want that to be behind the data. So I need to call that before geom jitter. That was another thing about the original, is that this grid line goes over the top of the data. Again, very small point, but whatever. Geom, indulge me. Geom vline x-intercept equals 0.5, and we'll then do line type equals dashed, and let's do line width equals 0.2, and then we'll do color equals gray 30, kind of a darker but not completely black color, and looks like that. I think theirs is like but the previous one was like a longer dash. I wonder if I can do like long dash. Nope. Is it? Ooh. Hey, long dash. I think that looks good. You do see some bleed through up here, and that's because there's transparency to the points, right? So it does kind of look like that line is going through there. But again, we do have the gray grid line behind it. So I'm going to get rid of that. And my way of getting rid of that is to use another geom vline. And I will make this solid. That's what the default is. And then I'll use the color of white. Oh, it's set with me. Let's see. Invalid hex digit in color or LTY. Maybe it's line type. Okay, I'll make that 1. Again, that's the default. Error went away. That was it. And so now we have this grid line at 0.5 with nothing in the background. I guess you can kind of see the border of the white line, just kind of the pixelation, but not to the same. I think it's clearer than what we perhaps had here. And maybe that gray is too dark. So let's maybe go to like gray 40. And I think that's good. All right. So let me clean up this code here because some of the stuff is going off the right side and I don't like having that happen. All right. So the next thing to take on the left side here are these grouping labels, right? And let's do that with annotate. And yeah, we'll do annotate and we'll do geom equals text, right? And then we need to give it X, Y, and then our label, right? And so the X is conveniently at 0.9. So we'll do 0.9. Let's see. Let's see. Mark's saying it looks like it's still a layer above data. And so I think that is because we have the alpha, right? So if I made the alpha, if I comment this out, it's upset with me. Oh, that's because I started something and didn't finish it. Let me comment this out too. All right. So now what you see is like it is behind the point, but when we turn on the alpha, it emerges, right? We can kind of see it, right? So I don't know. I'm kind of looking at this thinking like, I actually kind of like this. I don't know that we need the alpha, but I think the alpha is helpful to see the points. We could also make the points smaller, but I'm going to turn the alpha back on. And yeah, like that. Okay, cool. All right, yeah, so we were working on that annotate. And so our label is going to be the tax levels or tax labels. No, it's not. I'm confusing myself. So let's do 1 to 7. And then our label, again, is going to start at the bottom and work upwards, right? So we have like E, D, E, and then, or sorry, no, it's D. And then we have DE, DE, and then C, B, A. Add that in. And so then we've got, so it nicely adjusted our limits. And I put it at 0.9. I think what I meant to do is 0.85. So let's go back here, 0.85. And then let's do size equals, let's do 7. And we'll do size.unit equals PT. And there we go. We now have our grouping, right? And again, I don't like having that grid line run through those letters, I think, now that I see it. That grid line isn't really doing much, right? Like I could use like geom label to make the background white, and then I'd have like the grid line running through it, or I could just get rid of the grid line. And I think I'll get rid of the grid line by doing what I did back here, right? And so actually I can give it 2 x-intercepts. So I can do 0.5 and 0.85. And then let's put those on another line. And now we get rid of that grid line in the back. Although what I'm noticing is like a bit of a shadow there, right? I don't know if you can see that. So what I think I'll do is, let me just double check. What was my line width down here is 0.2. So I think if I make it actually a little bit wider, let's go up to like say 0.3 and maybe that shadow will go away. Yeah, that shadow went away. And I think I was noticing the shadow over here with this grid line as well, but now it's gone, I think. Or it's more gone. We could always up it just to be safe. I'll up it to say 0.5. Where were you? Let's make it 0.5 and not worry about that so much. Okay. So I think this is pretty good. Like one question still would be OTU versus ASV, which is better. Let's put a pin in that and we'll come back. So now what I want to do is work on panel B. And so again, panel B is going to use a different type of data. And so let's come back to GitHub. And again, this was in analysis send spec by level.csv. So we come back here and go to analysis send spec by level.csv. I want the raw. And so what this is giving then is the sensitivity for specificities going up by 1/100ths. Okay, so let's go ahead and plop that in, put that in quotes, and we'll do read TSV on that. Sorry, it's not TSV, it's CSV. So the question about adding p-values. So that is going to get really nasty really quick because we have 7 groups, which means there will be 21 p-values, right? That's going to look really nasty. Right? And so I think by having these groupings and saying we defined significance at whatever level would be the better strategy. I think adding like numeric p-values or the bars to indicate groupings like that would just be really painful. And again, I want my audience to see that like family, genus, and OTU stand apart from the others, right? And so I think adding the p-values with those bars is just going to make things really nasty. And or we could also point them to another file or another data file that says, if you want the exact p-values, then go look at this other file. But that would be my thought on p-values here. But again, with the significant ones, we're going to have one between A and B, B and C, A and C, C and D, C and D, E. Like we're probably going to have just as many, right? So I don't know, but anyway, and great to have you, Julian. Great to have you, the Pakshan from Kabul in Afghanistan. Welcome, awesome. So let's now work on this, and it should go a bit faster because we've already kind of created a lot of the styling and thought behind the jitter plot, right? So we're going to read that in, and I'm going to do a filter, and we'll filter to get specificity equals 0.9, right? And now we have go away. We now have, again, a 700 by 4 column data frame. And so we could then go ahead and pipe this to ggplot AES. On the x-axis, we're going to put the sensitivity. On the y, we're going to put the level. And yeah, and then I'm going to maybe annoy some of you by copying some of this down, right? So I'm going to, yeah, I'll just go ahead and copy the whole shebang down, as well as this ggsave. I'll save this as panel b.png, and then I'm going to look through here for things that we're going to want to change. I think this geom jitter will stay the same. The stats summary will stay the same. The annotate, I'm going to comment out for right now. And this will be wrong, but let's go ahead and run this. And it's upset with me because it doesn't like my scale color manual because I probably don't have color, right? So color should be group D. And I think I defined group D as part of AUC data back up here, right? So I need to go ahead and copy this down as well for my sensitivity data. So I'll grab that, and maybe I'll go ahead and call this send spec data, right? And then I can pipe send spec data into this. No error messages now. Now if I look at panel B and what I do with my original, we now have this, right? And that is not right. Is it right? No, it's not right. Let's see, what did I do? Send spec? Yeah, that's right. Okay, sorry. But like our sensitivities are fractions, right? They're decimals rather than percentages. So we can multiply that by 10 to get the percentages. And so to do that, let's come back up to our send spec data, and we'll do sensitivity equals sensitivity times 100 to get it to be percents. And there we go. We now have the 20, 40, 60. And that's all fantastic. If we think about, well, the label on the x-axis, let's change that because I will forget. So let's say sensitivity at 90% specificity. And I'm going to put parentheses with the percent sign in that because one of my critiques of the original was that I had the units on the x-axis text, right? Like 10%, 20%, right? That's just a lot of extra clutter that doesn't need to be there. That could have been next to the sensitivity with percent, right? So let's do that instead. And let's go ahead now and run this. And so we get something like that. And this looks a little bit funky though, because it's like, I don't know, like it's like we've got a couple different percent, 2% signs in here. Maybe what I will do will be this. Tell me what you think of this. Where'd my labs go? I'm gonna move this. I'm gonna do sensitivity there. I'm gonna put a backslash there. And that way then I've got sensitivity percent at 90% specificity. I don't know. And so see how that goes. Now what we've got are these breaks where I go 20, 40, 60. Originally we went 10, 20 to 60 with minor breaks. I don't know that we need the minor breaks. Let's go ahead and add those. So we can do scale x continuous and do breaks equals, and I'll do seek 10 to 60 by 10. And we'll get that. And it's adding the minor breaks still. So I could get rid of the minor breaks. So scale, so that's down here, right? So I'll turn that off. And so that, did it? Oh, yes, it's there because by default it's there. So let's do element blank. And so then those drop out. And I think that's a little bit cleaner than what we had originally. So let's see, we need to add these labels, right? And so we can do that back up here with this annotate. So I'll uncomment that. And so here we want it to be at 65, right? And go 1 to 7 again. And then the labels, again, go from the bottom to the top. And something that I thought we did was smart here was that we used a different, the other end of the alphabet, right? We've got 2 panels. And if we'd have used like A, B, C, D, then maybe it'd be confusing. Like, are these the same groups in both panels? It's like, no, we're using a completely different set of letters so they don't overlap. I don't know. Little things, right? So again, from the bottom would be Z, Y, 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 and then X, W, W. Like so. And there, well, that's the original. There we go. Okay. And again, I got those groupings. That's at 65. It doesn't fall on a grid line because I'm not showing the minor grid lines any longer. And I think that looks good. If I look at, like, let's look at both of these panels. So again, on the left, we have panel A, and on the right here, panel B. I don't know. One argument for putting back in the minor grid lines is that on the left, we're going in 500ths, so like 5 percentage points. I'll go ahead and put those back in. That's fine. I don't know. I feel like that is just kind of cluttered. But I don't know. I'll leave that there. And again, what I can do is I can bring in my geom_v line and do x-intercept equals 65, line width equals 0.5, color equals white, to hide it behind that label, right? So I can live with that. That's cool. All right. So we now have our panel A and our panel B, and I think that's looking good. We could perhaps go ahead and shrink the margin all the way around the plot. So let's go ahead and do that real quick. I will come back up here to the top and do like at the top of the theme function arguments and do plot.margin, and I'll do margin emptied. And so that's going to give the default, which is like 0 all the way around. And so we can see that that is really maximizing the space. And I will do the same thing for panel B down here. There we go. Okay. So now what we want to do is we want to bring these together with patchwork. So we'll come back up here and do library patchwork. So I am not an expert on patchwork. I don't use it every day like I do ggplot. And so bear with me as I go through this because we might need to look up some help. So the general approach is going to be like panel A plus panel B. And we're going to add those together. And then we're going to do ggsave. And we'll do like figure1.png. And we're going to use a width of 6 inches, right? So, but I need to define panel A and panel B. And so I can do that by coming back up to these ggplot statements up here. And I'm going to do panel A equals that, get that loaded. And then I'll do panel B equals that. And then I can run that and that. And then when I look at figure 1, voila, we get that. Right. And so, Julian's asking about GG arrange. I do not know GG arrange. I'll have to look into that. Yeah, I tend to use, we used to use cowplot, which was a package made by Klaus Wilke. And then we started using patchwork like this more frequently. So I think we'll roll with patchwork here. But what I would like to do is to get rid of this column of names, like these y-axis names for the sensitivity plot. And so there's a way to do that, but of course, because I don't use it all the time, I forget the syntax, but I know where it is, right? Like that's one of those things where I come to the website for patchwork. I'll go ahead and throw this in the chat for you all. And if I look at articles, it's going to be, maybe I don't know where it is. Let's try controlling layouts and like do like, I think it's something with gathering, controlling axes maybe. Aha, yes. So I can do plus plot layout axes equals collect, right? So you can see up here, they have the same y-axis in both panels. And then they use plot layout and they got rid of the y-axis text for the second panel. So I'm going to copy that, bring that in here, and see if that doesn't do the trick. And there we go. And of course, that's like they're right next to each other because I removed the margin all the way around. So what I will do is maybe add a little bit of space. And I wonder if there's a way to do that within ggplot. So add an empty area. I think like that's adding like a whole spacer, right? And I wonder if maybe we could do that with plot spacer. There's a way to set the width of the spacer. Let's see, we can use plot margin on each individual plot. Maybe that's what we'll do instead. Okay, so I'm going to come back up here, and he had these in parentheses, and we'll do theme and plot dot margin equals margin. And then on the right, let's make it like 5 and see what that looks like. And then we'll have those. And so that gets us space in between. We're probably going to want to put that our A and B on. So maybe we'll make that a little bit wider. So let's do 10, like that. And then, like I said, we want to put the panel letters. And again, I forget how to do this, so bear with me. Let's try plot assembly. And I'm coming down through here, looking for some indication of how to add a letter. Okay, don't think it's this. Controlling layouts. Oh. Let's see. Adding annotation and style. Tagging. I think it's tagging. Yes. So plot annotation like that. And add that. And let's see. What did I do in the original? Down here. So those are capital letters. Okay. So let's run that. And here we go. So we have those letters, which of course is taking a lot of space. And I wonder if there's a way, yes. So what we could then do is modify the theme, okay? Cool. So we'll come in here, we'll do plot tag, size, maybe I'll do 10, like that. And then let's do, I forget if it's face or font face. Oh, it's face equals bold. Something like that, right? And yeah, and maybe we can change, yeah. And then maybe here we can do like margin equals margin, T equals 0. That doesn't move anything. Or maybe we could do like minus 10. Oh, it's too far. Let's do minus 5, like that. Right. And then maybe on the left, we could do another minus 5. Something like that. Okay. So again, I wasn't going for like a perfect reproduction of what we had done originally, but I wanted to, I don't know, apply some of the new ideas I've been thinking about in terms of data visualization to recreate this plot. The one thing that I'm still thinking about is whether I want OTU or amplicon sequence variant. Let me go ahead and change that up here. So let's do OTU, ASV, and then I will comment this line out and then rerun everything. And then let's see what we get. So we get that, right? Unfortunately, I can't like toggle back and forth with before and after. I guess I can over here. So this or this. And again, this is what I have. I kind of don't mind the abbreviation here. I don't know. I think it's like in a matter of like your own personal sense of style and sensibilities, and would encourage you to think about it. But I think this is good. I change from what we had before to what we have now to make it better. Adding in this color, I think, was helpful. The original title was very descriptive, and so I think with coloring the points like this, we can get something that is more declarative. And I think what I had in this mock-up, right, like this could be a good title. For family, genus, and OTU level classifications had significantly better performance over other taxonomic ranks, right? And then that's declarative. And then, of course, we wouldn't, in a paper, we wouldn't have color in the title, but it would make it clear like, oh, this is the family, genus, and OTU lines. Those perform significantly better than the other taxonomic ranks, right? Okay, so now what you're probably waiting for is for me to talk about like, how would we change this to make it a plot for a paper, right? And so again, what I would do is strip things out, right? And so I'm going to use panel B because, why? Because I feel like panel B is like what's important and where it's at. And yeah. So let's go down to where I have the code for panel B. And I'm going to copy this down to here. And then I'll put in here, work on creating panel B for standalone figure for a talk, for a slide, right? So I'll plop that in, paste that in, and go ahead and remove that. And so we also have more real estate, right? So I can make it bigger. So I could make it maybe like 6 inches wide and, go away, okay, 5 inches high. Maybe we'll do 4, right? Because it's going to be on kind of like a widescreen layout in the slides. What I'm thinking about is let's get rid of the background points, because again, I think those are going to largely confuse my audience. Again, remember that like if you go and give a talk to a general biology department, they are not going to be the same audience as like a microbiome audience. Or if you go talk to cancer researchers, they're not going to be a microbiology audience, right? So they might need you to spell out OTU, ASV, things like that, right? So you got to think about your audience when you're doing some of this. So there we go. Cleaning things out. I think for a talk, we can also get rid of these labels because I'm going to spend, as an audience member, I'm going to spend my whole time trying to figure out what goes with what. In reality, I've got the color to tell them what is most important, right? And so, again, they can always go look at the original paper. They can ask you a question during the Q&A. But what we're trying to do when we give a talk is tell a data-driven story about what really motivates us to go to work every day, right? And so I don't feel the need to like overwhelm my audience with all sorts of information in the slides. I really don't think that's helpful. So let's go ahead and get rid of that annotate. And so we also, I think, I'm wondering like why it's still so wide and why it's not zooming it in to 50. And that's probably because we have a GeoMV line there. So let's go ahead and remove that. Yep, right here. And so now we're zooming in quite a bit. So that's cool. Let's go ahead and make our axis text larger because, again, you put this on a slide deck, you want people to be able to see it. My thought would be like if I have got a lot of index cards on my desk, right? But like if I have an index card here, I want to be able to like put that on this index card, put it at arm's length, and then like be able to see what I'm trying to show my audience, right? Because that's kind of the scale of perhaps your average or audience member in the back row trying to see your slide, right? So we want to make it visible to your audience. And so I think, again, like thinking about like an index card is a good way to think about that. So Mike says, it's a shame that the significance part is not clear from the plot. I see a lot of overlapping range bars. So you're thinking like p-values or something like that, coming back to that. Yeah, I don't know. And again, this might be a place where like a standard error would be a little bit more helpful because each part and each range represents 100 points, right? And so, and it's 100 different permutations of the data set, right? So, yeah. But okay, so let's make the text larger. And so again, we're going to come in here and I've got like this axis text Y is at 7. So let's go ahead and make that say 12. And so that's a better size. Maybe we could even go up. So that's 12. That's fine. And let's do axis.text.x element text size equals 12 as well. So those numbers are bigger. And then our sensitivity and specificity, the title could be larger. Let's maybe make that like 15. Something like that. Okay. And then maybe what we want to do is go ahead and make the points bigger as well, right? And some of this, perhaps you could imagine, like, let's just keep it at like 3x6 or 3x4 and then pull things apart. But I think when you do that, you tend to get pixelation. And again, I think it's helpful to try to design for the size that you're going for. So in here, then we could do size equals 2, something like that. That almost looks a little clownish. Maybe we'll do size equals 1.2, something like that. And then maybe that, let's see what happens if we make the line width a little bit wider too. Something like that, right? So that's then more pronounced. And I'm thinking like maybe even these taxonomic levels could be bigger. So axis title, axis text Y, let's take that up to like, say 15. Something like that. So yeah, okay. Maybe what I'll do is having this go to like the edge of the screen is making me a bit nervous. So I'm gonna come back to like a normal margin. And let's go ahead and put on a title. The challenge with the title is like, if we do this in PowerPoint, maybe I'll go ahead and open PowerPoint. Open, okay. Let's see, applications. I mean, of course you could do this with Google Slides, but I'm not that quick. Let's see, let's do new slide. And what I could do is like delete that and then grab, oh, where'd you go? So this is panel B, right? Plop that in and like that, right? So the problem with like putting the title on the figure itself is that it's going to be, there's ways around it, but it's basically going to be right over the figure, right? And so then you would want to make your figure as wide as the slide, which might be overkill, right? And so maybe what would be better would be then to put the title up here. But, right, and that's kind of what I did in this mocked up version of slide 2, right? Like, I could see doing this, plopping that in, and yeah, like, oh, whatever. This is not a PowerPoint live stream, but we could also like play with, I like to make my titles bold, and we could make these the blue color, right? Something like that, right? We could match the hex code of this blue with that blue, right? Something like that. But let's maybe do it all within the figure. Yeah, and you can change the pixelation, right? And let's see. So hold on to that thought, Mike. I'll probably come back to that if we have a chance here. So we could definitely change the resolution here, right? I think you could do like, is it DPI? So we could do like forget what the default is. What is the default? Probably told me. I think it's 300. So anyway, you can put in the number for the resolution. But what I often see people do is they make a big figure and they leave the text the size of kind of the default size. And so you get these big figures with lots of data or big visuals like this. And then the text on the axes is still like 8-point font relative to everything else that's at like 20-point font, right? And so that's really hard to see what's on your axes, or things don't look perhaps properly scaled to each other, right? So that's something to think about perhaps. And yeah, anyway. And as I look at this, I see I've got 20, 30, 40. I could go ahead in here and make my breaks go by 5s, right? To get more of those grid lines. Wait, if I go back to 10, oh, that's because, okay, yeah. Let's see, if I go back to 5 and then turn off the minor grid lines because it was putting in an extra grid. Why are you putting that there? Oh, right, because this needs to be element blank. I keep doing that. Okay, so it should be element blank. And I forgot to put parenthesis on this, so it yelled at me. Okay, so we get something like that, okay? So let's go ahead and put the title in. And here we'll do title equals this, right? And I'm going to use some HTML in here. So I'll do span, and we'll do style equals, and it's been a while since I've done this, so bear with me. We'll do color colon Dodger blue, like that. And then I had this go through classifications. Turn off the span. And so to get that HTML to render, we need to do library ggtext, right? And then in axis title, or sorry, plot title, we'll do element markdown, which is not probably what I actually want, right? But you can see I've got that. And what I actually want is element text box simple, and this will wrap the text for me. And so as you can see, it wrapped it for me. I would like it to be bold and probably bigger, right? So let's do like face equals bold, size equals 20. So this is kind of too much. It's also, it's left aligned on the plot, or sorry, left aligned on the panel, not the plot. So let's go ahead and modify that. So we'll do plot title position equals plot to get to be left justified on the plot rather than the panel. And so then that moves that over like so, right? And yeah. Now if it were for like a slide deck, what we could do would be something like margin equals margin, L equals minus 30, R equals minus 30. And that didn't work. And I think that might be because we need our margin to be plus 30 on the left and right. Something like that. And so we could play with those numbers to get the plot to move in relative to the title, right? Yeah, anyway. And we probably want a little bit on the bottom. So let's do B equals 10 to get some space there, right? Something like that. And I'm going to up this a little bit more because I can't help myself. Let's do 60 and 60. Yeah, something like that, right? And actually, yeah, I think ultimately this is really painful, right? To make this as a slide is going to be really painful because you'd have to save your slides in the right format. And I think ultimately that's just going to be really painful. I'll leave that in the code. And if I haven't already mentioned, I will leave the code. I will leave a link to the code down below in the description for this episode. But yeah, all right. So there we go. That's what we had. And we could do things like come back up here, and maybe what we want to add would be like a caption to say like each point represents the mean of 100 random splits into a training and testing set. Okay, something like that. And yeah. And then this is by default going to right justify on the plot, right? I think what I will do is I will add the title back in. Sorry, but I'm not going to worry about making the title wide and the figure more narrow, right? So, yeah, so we get like this. All right, my margin is still 60. So I'm gonna remove that, and I will maybe make my width wider. Oh. Something like that. I don't know, maybe that's too wide. Let's do 6 and 4. Something like that. And let's shrink the line height of the title. So 0.9. And then let's add margin to the bottom. And then we'll do margin equals margin, B equals 10. Get a little bit of space there. And I don't know. I feel like maybe now some of our fonts are a little too big. Maybe we could put this sensitivity over one line. Something like that. And we could make our caption be left justified by doing plot caption equals element text hjust equals 0. By default, it's 1. And then we could also do plot.caption position plot. And then that would put that caption off to the left, right? Ultimately, I feel like it's probably the best strategy to make the plot without the title and the caption, insert that into your software for making a presentation, and then add in those titles and captions, right? But be careful that you're not overwhelming your audience with all sorts of stuff you want them to read, right? So something to think about, right? And I will try one last attempt on this margin issue. So we'll do plot.margin equals margin. I think I did L equals 60, R equals 60, and then maybe on this, we'll do L equals minus 60, R equals minus 60. And I forgot something. Oh, I forgot a comma here. something like that. Although maybe need a little bit of margin at the top. Oh, okay, and then the caption needs to be at -60. And it needs some top margin. All right. Something like that, right? And so you can begin to think of this as being like a slide for a presentation. So anyway, let's see. Mike asked about how, so this is, let me stop and say, like, this is probably how I would design panel B for a slide deck with all the caveats I mentioned. And if I, that's my original, this is my remade of the paper, right? So again, like the main difference between like panel B here and the same panel is I'm basically making everything bigger so that like somebody in the back of the room can see it. I'm trying to simplify the presentation by getting rid of like all the extra stuff, right? Because again, your audience is going to be trying to digest this while you are talking to them, right? And so they're trying to like listen to you, but they're also trying to like read the data, right? And so I think it really helps to make these as simple as possible and to remove as much as possible and make things as big as possible. Minimize your use of color, and then try to tie your color to the other stuff, right? And a great bit of wisdom that I heard from a woman named Cole Nussbaumer-Knopfleck, who does a lot of data visualization talks within kind of the business world, is to make everything gray and then add color where you need it to make a point. Now, with a slide deck, you could show the same figure 5 times with 5 different colors to call out what you want them to see, right? I think that would be a really unique way to present data compared to a lot of the seminars that I've sat through where it's literally copying and pasting. I mean, I do the same thing, copying and pasting things like this into PowerPoint and then saying, we're going to talk about this. I know you're distracted by that, but don't look at it. You know, it's just too much, right? But it is a bit of a, I think, culture change in how we prepare our talks to make slides, to make figures specifically for the talk rather than for a paper. They are different media that we're presenting in, and they have different audiences. And I think we need to design accordingly, okay? All right, so Mike asked about standard error instead of standard deviation. And I'm gonna come back up here. And so we can set that in our stats summary, right? So we have mean SDL, and if we do mean SE, let's see what that gets us in panel A. Maybe that's it. Let me look at the help for mean SE. So the multiple is 1. So let's come back up here and do multiple equals 2. I think it's technically like, yeah, it's 2. Or is it 1.95 for a 95% confidence interval? But, or yeah. So there you can see that's plus or minus 2 standard errors, right? So maybe that's a bit more compelling. And so let's use that, right? So I did mean SDL. Let's change it to mean SE. I think that's it. All right. Let's save and run all that. And so here is what the panel B would look like for a figure. Here is what it would look like in the paper, where here 2 standard errors is smaller than the size of the point. I suppose our standard error is a whole nother kettle of fish for discussion that I don't want to get into today. But again, hopefully this gives you something to think about, again, about how you would visualize data or present data differently in a slide deck versus in a paper. And I know that it is far easier for me with my busy schedule and just time and commitment, or the amount of time that I have to make new presentations is limited. And so it's very easy to copy and paste a figure from a paper into the slide deck. And I think that ultimately does a disservice to my audience and makes it harder for me to tell the story I want to be able to tell to my audience. And so I would really encourage you to think about who is your audience, what is the medium in which you're presenting your data visualization, and go from there. If you have thoughts about any of this, by all means, leave it down below in the comments. I'm sorry for some of the connectivity issues that I've had as I've been presenting this live stream today. Hope you're still able to get something out of this and learn. Again, if you want the code that I've generated today, it'll be available down below in the description for today's episode. With that, I will say goodbye and sign off, and I will see you next time.